In this intelligent terminal equipment manufacturing plant in southwest Nanchang, 4 newly arrived humanoid robots have successfully been integrated into the traditional mass production line for joint production.
Next to me are 2 new employees who are steadily performing a series of fully closed-loop operations on the high-speed production line, such as material picking and high-precision placement. What the robot is doing right now is placing a component into the equipment. Don't be fooled by the fact that it picked it up again after putting it down. This is because the robot just autonomously detected a positional deviation on the production line, so it performed a repositioning. The person in charge told me that humanoid robots can not only achieve real-time data exchange with the factory's systems and equipment to ensure stable production, but also offer greater flexibility and adaptability compared to traditional robotic arms, allowing them to adapt to different workstations on the production line within a short period of time.
The reporter learned that currently each robot completes a task in about 18 seconds and can produce approximately 300 items per hour, with an overall operation success rate of over 98.5%. Moreover, the robots can quickly adjust to produce different models of products on the production line without the need for custom tools.
This successful implementation actually signifies a qualitative leap in the reliability and consistency of the robot hardware, the maturity of the algorithms, and the completeness of the entire system. Only with these advancements can such stringent standards required for industrial applications be met, marking its transition from the research and development phase to a brand new stage of real-world deployment.
The factory manager told reporters that the successful integration of humanoid robots with traditional production lines not only effectively mitigates the safety risks associated with traditional employees performing monotonous and repetitive tasks, but also significantly reduces the labor intensity of frontline workers. This shift enables employees to move from highly repetitive and high-risk positions to lower-risk roles that are more valuable and technically demanding, thereby achieving simultaneous improvement in their personal capabilities.
It turns out that the workers from these 2 positions have been reassigned to handle the maintenance and operation of the robots.